Hello boys and girls, welcome to Science Arena. I am Monica and we are doing covalent bonds today. So what are covalent bonds? How are they formed? Is what we are going to discuss today. So covalent bonds always happen or form between two non-metal atoms. Alright, so let us take an example of two chlorine atoms bonding together. Alright, so chlorine atoms have 7 valence electrons. So their octet is not complete. So for certain, they are not stable. So they would try to become stable. How do they try to become stable? Is it possible for the chlorine atoms to give away electrons or take in electrons and become stable while they bond together? Well, the answer is no. Why not? Because they are both acceptors of electrons. So in the absence of a donor, where do they get their electrons from? So this is also an acceptor of electron, this is also an acceptor of electron. There is no donor. So what happens? They try to bond together by mutual sharing of electron pairs between them. What does that mean? So this chlorine, which has 7 valence electrons, it shares one of its electrons with the neighboring chlorine atom. So what has happened? It has 8 electrons now. Now look at the other chlorine atom. It has 7 valence electrons. So it shares one electron with the neighboring chlorine atom. So this chlorine also has 8 electrons now. So they have both become stable, acquired their octet. And this electron pair which is shared between the two non-metal atoms, right, is symbolically represented by a single dash between the non-metal atoms, meaning one electron pair being shared between the two non-metal atoms, wherein they are both equally contributing in the bond pair, right? So if you look at two electrons contributed here, one by the first chlorine, the other by the second chlorine. So they are mutually sharing the electron pair wherein they have both equally contributed, right? Now if you take an example of, so this is a single bond here. Now if you take an example of oxygen, let's see how oxygen works here. Now oxygen molecule again is a diatomic molecule. That means two oxygen atoms make one molecule of oxygen. So oxygen again is not stable, right? So oxygen atom is not stable. So if you have two oxygen atoms bonding together, each having 6 valence electrons, right? So this also has 6. The other oxygen atom also has 6 valence electrons. Well, they are not stable. So how would they try and become stable? The first oxygen has 6. It needs how many more to become stable? 2 more to become stable. So what does it do? It shares 2 electrons with its neighboring oxygen. Well, now it is 8. Similarly, the second oxygen, which has 6 valence electrons, takes in or shares 2 electrons with the first oxygen atom. Now they have both acquired their octet. Well, what has happened here? If you look at this space, there are 2 electron pairs which have been shared between the two non-metal atoms, and it is represented by a double bond, right? So each bar representing one electron pair shared. So this is the first bar, this is the second bar. So 2 electron pairs being shared means it is a double bond between oxygen atoms. So 2 electrons contributed by the first oxygen atom and other 2 contributed by the second oxygen atom. Now there is a way of interpretation here. So there is a concept of covalency. Now covalency of oxygen is said to be equal to 2. Why so? Because it has shared 2 electron pairs wherein each atom has been contributing 2 electrons. So that is why oxygen has a covalency of 2, right? Similarly, chlorine has 1 as its covalency. So covalency of chlorine is 1 because each of these chlorine atoms are contributing 1 electron each. Right? Okay, let's move on to a nitrogen molecule. A nitrogen molecule again is a diatomic molecule. Meaning in the molecule, 2 nitrogen atoms are going to bond together. And how are they going to bond together? Now we know that nitrogen has 5 valence electrons. So 1, 2, 3, 4, 5. The other nitrogen also has 5 valence electrons. So certainly nitrogen is not stable. What does it do? So it shares 3 electrons with its neighboring nitrogen. The second nitrogen also shares 3 electrons with its neighboring nitrogen atom. So what has happened? A triple bond has been established between 2 nitrogen atoms in the molecule of nitrogen. Right? That means 3 bars indicating 3 electron pairs. Each of these nitrogen atoms contributing 3 electrons. So first contributing 3, the second contributing 3, right? So the covalency of nitrogen is 3. Yes? Alright. Now, does it always happen that the nonmetals of the same kind bond? Means nitrogen with nitrogen, chlorine with chlorine, hydrogen with hydrogen? No. You could have different types of nonmetals bonding, right? Let us take an example of water molecule. Okay, so water has 2 hydrogen atoms and 1 oxygen atom. So oxygen having 6 valence electrons and hydrogen having 1 valence electron. Alright, so both of these are not stable. So what happens here? The hydrogen takes 1 electron or shares 1 electron with the neighboring oxygen and becomes stable. It has acquired 2 electrons and hence it is satisfying the law of duplet. Now if you look at this hydrogen, this also has 2 electrons now, having shared it with the oxygen atom in the molecule. Oxygen has 6, needs 2 more. So what does it do? It takes 1 each from these 2 neighboring hydrogen atoms. So how do we represent this? Hydrogen single bond because 1 electron pair shared. Oxygen single bond, again 1 electron pair shared between oxygen and hydrogen. So water molecule has 2 single bonds. Now take an example of, let us say we have, let's take an example where there is a double bond. Let us take up carbon dioxide. Okay. So if you look at carbon dioxide, this is the formula of carbon dioxide. Well, there are 2 oxygens and 1 carbon. So 1 oxygen, the second oxygen, and I have 1 carbon. Carbon having 4 valence electrons. Oxygen having 6 valence electrons. All of these atoms are unstable. So how do they try and share electrons here? Oxygen has 6, needs 2 more. Well, it shares it with the neighboring carbon. Oxygen has 6, needs 2 more. It shares it with the neighboring carbon. Both the oxygens have their octet complete now. Carbon has 4 electrons of its own, needs 4 more. So what it does is, it basically shares 2 electrons each with these 2 oxygen atoms on either side. So if you look at it, there are 2 electron pairs being shared between carbon and oxygen each time. So how would you represent this? Oxygen, double bond, carbon, double bond, oxygen. So this is how a carbon dioxide molecule looks like. Okay. So a molecule of carbon dioxide has 2 pairs of double bonds. Right? So these are some examples of covalent compounds. Now let us take example of a triple bond here. Okay? So a triple bond. So nitrogen bonding with nitrogen. I think I have done that. right? Alright, let us take an example of C2H2. C2H2. Now C2H2 is called ethine. You will read this in carbon and its compounds. Okay. So ethine has 2 carbons, 2 hydrogens. So if you have 2 carbons here and 2 hydrogens here, symmetrically arranged on either side. Now hydrogen has 1 valence electron, carbon has 4 valence electrons. This carbon, alright, sorry, let me place it slightly differently. Now if you look at this carbon, this will also have 4 valence electrons. Okay. Now what happens here is the hydrogen shares 1 electron with the neighboring carbon and becomes stable. This hydrogen will also share 1 electron with the neighboring carbon and become stable. Now look at the carbon here, it has 4 electrons of its own. So what it does is, it needs how many more? 4 more, 3 of its own, 2 of these hydrogens, and 1 of this hydrogen, and it's still running short of 3. So it shares electrons not only with the hydrogen but also with the neighboring carbon. So if you look at this, 3 here, the 4th here, 1 of hydrogens and 3 more from the neighboring carbon. So it has it has completed its octet now. Now if you look at this carbon, so how many does it have? 3 on this side, the 4th is here, 1 from hydrogen, needs 3 more, so it shares it with the neighboring carbon. Well, they all have their octets and duplets completed now. The carbons completing octet, the hydrogens completing duplet. Now how would I represent the bonding here? Hydrogen, single bond carbon, triple bond carbon, single bond hydrogen. So there is a triple bond between the 2 carbons, and there are 2 single bonds existing between the carbon and the hydrogen atoms. So this is how you represent covalent bonds. Alright. So now there are certain specific characteristics these covalent compounds exhibit. So if you try to basically pen down certain important characteristics of these covalent compounds, what can we write here? So covalent compounds are compounds wherein the bonding happens between 2 non-metal atoms. Right? So it is always between 2 non-metal atoms. Now it happens because the bonding atoms mutually share electron pairs between them. So not only is the fact that the non-metal atoms are bonding together, they are both mutually sharing electron pairs between them. Yes. Now as a result of sharing of electron pairs here, do you realize there are no ions formed? There is no loss of electron or gain of electron. So there is no ion formed. So what has been formed? So they are forming covalent molecules. There are no ions formed. Yes, so an interesting character. Right? Now, because of these properties, there are certain characteristics these covalent compounds exhibit. Now, if you try and compare it to the ionic compounds, if you remember, had strong electrostatic forces of attraction between the bonding atoms. Now, in covalent bonds, the kind of forces of attraction are weak, and they are called the van der Waals forces of attraction. Now, these forces of attraction being weak, these atoms in combination exist as molecules. Alright? And if the van der Waals forces of attraction are weak, what does it mean? That a very little amount of energy will be required to break them. So naturally, The covalent compounds have to have a low melting point, boiling point. With a little supply of energy, you can very readily break the bond. Well, that is why they have a low melting point, boiling point. So the physical state of occurrence is in all three forms. So they exist as softer solids, as liquids, and in gaseous state. So all the three states. Remember what ionic compounds were in their physical state of occurrence? They were solids, right? So very different because of the fact that covalent compounds have weak van der Waals forces of attraction. They exist in all three physical states, right? What about their solubility? These covalent compounds are insoluble in water but soluble in organic solvents. So organic solvents क्या होते हैं? So you have carbon tetrachloride, chloroform, benzene. They are some of the organic solvents, right, in which the covalent compounds are soluble. What about their conductivity? They are poor conductors. Why so? This is because they have molecules, they have no ions. So in the absence of ions, the covalent compounds are poor conductors of electricity, right? So these are some of the basic properties which are contributing to certain specific characteristics these covalent compounds carry, right? So I hope I have been able to help you through understanding covalent bonds. If so, I would appreciate it if you could share, subscribe, and like the channel, right? And please do stay connected. We'll love to have your feedback here. Thank you so much.